do one more example involving Euler's method. This time dy dx is equal to 1 minus the quantity x divided by y. And the initial condition is that it goes through the point 1, 1. All right. We're interested in finding the function's value at 2. Quick time out here. In both of our examples, we've gone up 1, trying to approximate a value of the function that's one x value higher. It doesn't have to be that way. We could approximate at, we could be interested in f of 3 or f of 5. We could be interested in f of 0. We could actually go down. If the value of x drops, then that just means that the step size, the delta x, if you will, is negative. All right. But if the x is increasing, then delta x will be positive. And again, it can go by tenths, it can go by halves, it can go by full values. It all depends on how many steps you need to take, which again, on the exam is going to be 2. And how far the distance is between the value of x that you know and the value of x that you're interested in finding. Okay. So we have the 1 and the 1 in there already. Okay. We know that the new y value, so f of 1.5, because once again our step size is half, f of 1.5 is approximately equal to the old y value, which is 1, plus dy dx times the step size, which again we mentioned was half. So we have 0.5 here. Okay. So we need to find our new our dy dx at this coordinate, and if we plug in 1 for x and 1 for y, obviously our fraction is equal to 1. 1 minus 1 is equal to 0. So we have a 0 here and there as well. All right, so adding this up, we can see that this is obviously going to be 1. So in our new step, right, because our goal is to get to 2, we have to go one step at a time, and each step size is a half. So at x, when x is 1.5, the y value is approximately 1, right? We know it's not, but it's close, according to Euler's method, right? So now we need a new dy dx to help us find our final answer there. What is the function's value at x equals 2? So we do this all over again. F of 2 is approximately equal to f of 1.5, which we know is 1, all right, plus, and then we have our step size once again is a half. The question is, what's the derivative's value when x is 1.5 and y is 1? Right? So we go back up here. We have 1 minus x is 1.5 and y is 1. So 1 minus 1.5, which is obviously negative a half. Right? So that negative a half is right here and right there as well. And therefore, our final y value that we're interested in, 1 plus negative a half times positive a half. So this is negative a quarter. So we're going to take away a quarter from 1, which is 0.75.